Oh, thank you very much for the opportunity to be there remotely with you. I just had a question about whether or not you can hear me. If you can hear me, I guess wave at the podium. That's a picture I see.
Yes, we can hear you.
Or if you have. Okay, great. Okay, great. So I've shown my slide, and I appreciate the opportunity to be there. The topic I'll discuss today pertains to post-wildfire drinking water contamination, chemical contamination, and the natural environment and built environment kind of collide in this space. I want to thank Dr. Kaiser, Dr. Ward, members of the Academy and organizing committee, and Wayne for introducing me there. And I really wish I could be there, but I had some personal duties at home that didn't allow me to get on a plane and come back. So my Purdue University and Manhattan College team members and I have been involved in the response and recovery for the Camp Fire since January 2019. In January, I was called by the Paradise Irrigation District, one of the utilities there, for help. After the Tubbs fire in Santa Rosa, I was actually called too about how to decontaminate their system and conduct testing after that. But I primarily have been involved with the Camp Fire. So this first slide really goes to the issue of the changing climate, and wildfire risk is growing. And these events can trigger what we call technological disasters. This is where a natural hazard or a man-made fire hazard causes damage to other infrastructure, whether it's communications, transportation, water and sewer systems. And that can really exacerbate the ability of a community to recover rapidly or to resume some type of normalcy after the incident. As we all know, the most deadliest and destructive wildfires have occurred at the wildland-urban interface. The two I'm going to talk about are the Tubbs Fire and the Camp Fire. And as the picture on the right shows, this is just an image of a burned property in the Paradise Irrigation District area, which is in the town of Paradise. Me as a water engineer, water inclined plumbing person, I see water heaters and other things. But before this fire affected this property, there was a family living there. They had lives just like all of us do everywhere around the country and world. And so drinking water is really critical for community health, safety, and economic security. I think if you don't have drinking water or a way to get water, it's going to be pretty hard to have a sustainable community. And here you'll see buildings with trees, a street, a hydrant, and other above-ground objects. And when wildfire comes through, it affects these above-ground objects. But you also have systems with private wells. And private wells are individual houses or communities of houses that receive water from a well deep in the ground, and those wellheads and wells can be affected as well. There's two different responses here. One is the public water system, where you have these water distribution system pipes on the left-hand side, where the water goes underneath pipes buried in the street. Then they cross over this invisible line called private property. They go through this service line, this buried piping. It could be plastic, it could be metal. It goes through a meter and then into the home. With private wells, those individuals primarily rely on their own resources, talking to plumbers, talking to their well drillers for advice, whereas these other larger systems rely on their public water suppliers. So the next slide shows some details about the Tubbs fire and its water contamination issues. The fire began and was contained in October. We've heard a lot about that in the last hour on that really excellent video that the University of California, Davis created. It burned about 30,000 acres, and some of the burn area was within the city of Santa Rosa. In the city, there are about 2,500 parcels burned, properties burned, and because of the water distribution system's loss of pressure, the city issued a boiled water advisory. And boiled water advisories are common when there are concerns that bacteria could have been drawn into the water system through hydrants or through broken pipes or whatnot. And by boiling water, you would kill the bacteria so that a person drinking it would not get sick. Well, about a month later, the city received a drinking water odor complaint from somebody living in one of the affected areas. And the city investigated and did chemical testing and discovered VOC contamination of the drinking water. The problem here that was discovered in the campfire was that the water treatment plant was creating safe drinking water and providing it to their distribution system. But the chemical contamination was from the distribution system pipes and tanks and valves and fittings, and that is where the problems were. The contamination was just associated with the area affected by the fire. Benzene was one of the chemicals present. You may have heard about this, but there were a variety of other chemicals that were also detected in the water. As soon as the city realized that they had unsafe water in their drinking water distribution system, they issued what's called a do not drink, do not boil advisory. They did not want people boiling the water because the chemicals would be volatilized, so they would come out of the water and you could actually increase exposure. They had about 352 parcels affected by this, only a few water mains, hydrants, meters, and about 5.2 miles of their system. All in all, about 13 standing homes that were occupied were affected and less than 20 people. And so here we are at a scale of there's 175,000 people on this public water system and less than 20 people are affected. Now, subsequent testing over the next 11 months revealed much more VOC water contamination at levels that we've really never seen before elsewhere. The response and recovery was overseen by California's Surface Water Resources Control Board and US EPA Region 9. Initially, the idea was to remove and replace all the affected system. That was going to be about $44 million, but by testing and replacement, they were able to spend only about $8 million. There were multiple chemicals contaminated, and multiple VOCs exceeded acute and chronic exposure limits. There are several lessons learned here. Hold on one second, please. There were a few lessons learned. You can see those there, and that water was tested for a number of chemicals. Repeated location sampling was necessary to find contamination. Stagnation or soak times, you needed the water to sit still so that they could find contamination, and it had to sit still for a while, maybe 72 hours, to allow the chemicals to desorb from the contamination. Sometimes benzene differences in duplicate water samples for a single location were plus or minus 77%. You would take a water sample, and the second water sample you would take would be 77% different than the first one. And so this is simply due to the scale of contamination. 0.5 parts per billion was the level at which the city decided that there was contamination of benzene in the system and that asset had to be replaced. Now, this is lower than the 1 part per billion limit that California sets for its drinking water standards, but 0.5 was used as a decision limit because of concern that it was an active desorbing or chemical leaching process from the contaminated infrastructure. And so if they sampled the water one day and it was 0.5, if they came back the next day, maybe that water would have been 0.7 and there would have been contamination that they would have had to deal with. So they found very high levels of contamination in some parts of the system. To be clear, there's no typo. They found a maximum of 40,000 part per billion of benzene in some parts of their system, thousands to hundreds of parts per billion of benzene and other VOCs. They removed all contaminated hydrants, mains, air release valves, blow-offs, and service lines, and then they had to conduct long-term monitoring. The 2018 campfire was simply a different scale. I show you on the right-hand side an example of the map. The fire strafed across Butte County. It affected entire towns, half of Magalia, Concow, Yankee Hill, and others. And I know a lot of attention is paid to Paradise, and it is a large community, but other communities were also affected as well. This map here is an image of the town of Paradise and the burned and destroyed buildings in the town of Paradise. Each red dot is a destroyed building. Most of the town of Paradise was destroyed. What you can't see are black dots. Black dots are standing homes throughout the system. Prior to the disaster, there were water lines underneath the street, and these water lines then conveyed water basically from the top of the slide there all the way to the bottom. And so while the properties on the surface burned, the water lines primarily remained intact below ground. The next slide here shows you 13 different water systems that were affected by the Camp Fire. Over 40,000 people were issued a boil water advisory, and so while only 26,000 live and are served by Paradise Irrigation District, another 14,000 were affected. And so, as you can see on the left-hand side of the screen, this lists the different water systems that were affected. Paradise Irrigation District is one. Del Oro Water Company, a private water company, had 5 systems that were affected, and a whole host of other smaller water systems were affected. Often not talked about, however, are private wells. There were about 2,400 private wells in the Camp Fire burn area that were affected, and they were also issued warnings about contaminated water in their wells. There were 2 different experiences experienced by residents who received water from 2 different water systems. DOWC is the Del Oro Water Company, and PID is the Paradise Irrigation District. So if you look on this slide here on the left-hand side of it, you can see the date the fire began, and then shortly thereafter, boil water advisories were issued to the communities, the PID customers, and the Del Oro Water Company customers. In the Del Oro Water Company lifted its boil water advisories. This is typical. They issue boil water advisories after depressurization, and after they plug the leaks and provide pressure to the system, they lift those advisories. Well, shortly thereafter, they conducted testing, and they found benzene in the 2 of the 3 Del Oro Water Company systems that they tested. The Paradise Irrigation District, once they learned about this, they didn't have any of their own testing data, but they issued a do not drink, do not boil advisory, much like Santa Rosa did. And then over the next 2 to 3 months, there's very different experiences that PID and the Del Oro Water Company had. Initially on December 24th, the state believed that if the water didn't have an odor, it was safe, which was a mistake looking back, and testing was needed. And so over the next 2 to 3 months, you see a change in how contaminated water was handled and investigated. The next slide shows standing homes scattered throughout contaminated water systems, and this is just the PID example. On the right-hand side, you see a map of the town of Paradise. Anytime you see a purple dot, that's a standing home, and the green dots are commercial buildings that are standing. And one of the issues here is that these standing homes, sometimes there's one home on a street of 10 burned lots. And so there's no other family living on that street except this one family surrounded by 10 burned lots. So this poses a problem because lower water use happens, as well as the system, as it turns out, became contaminated, and then that contaminated water moves around the area due to this odd demand that's used with these sporadic homes located throughout the system. Here's 2 images of some infrastructure. Some water meters did not survive. There was a lot of plastic water meters used in the campfire burn area. And then some plastic pipes and other plastic materials, gaskets and stuff, melted, decomposed thermally, and cooled in place. And so this is, on the right hand, you see a picture of a plastic pipe with another piece of plastic that seems to have cooled inside it. Some of the meters were not there was no visual damage to the meters, but they are chemically contaminated, and so they have to be tested because they are secondary sources of contamination now in the system. And many of these, again, are plastic as well. To look closely at the data, reviewing the Santa Rosa, PID, and Delaware Water Company distribution system data, these are samples that they collected at their fire hydrants or at blow-offs or sampling stations out on the streets. And here we're comparing the Tubbs fire versus the Camp fire. And there's one really takeaway message here is that the city of Santa Rosa had a very small amount of its system affected. It has a tremendous number of water samples collected, and they had their own commercial laboratory in-house. And so they were not having to send samples 30 minutes, 45 minutes away and waiting for a commercial lab to turn around that information. And so one of the reasons why there's just so few samples collected in the campfire area for water sampling is because of the labor and the manpower needed. In addition, Santa Rosa's system was not as affected as the PID system or Delaware Water Company system, where they saw 90%, 50% of their infrastructure destroyed. I'll bring your attention to benzene. A lot of people talk about benzene with this fire. Benzene is only one of many different chemicals that have been detected in the water. The state found in the Paradise Irrigation District system more than 2,000 parts per billion of benzene in January. Delaware Water Company has found benzene in 2 of their 3 systems. And the takeaway message here is that a lot of people compare these chemical levels to long-term exposure standards, but there's also acute exposure risk. And acute exposure risk can cause headaches and a whole bunch of other symptoms that are not necessarily that are not long-term chronic risks. So naphthalene and benzene exceeded both of their short-term exposure limits. Possible sources, there's been a lot of debate about where these chemicals are coming from. We think that there's 2 main hypotheses. The first one is thermal decomposition of plastics. This is when you heat plastics up to a certain temperature, you can cause them to basically thermally fall apart. You have carbon-carbon bond breakage. It is not melting. Melting is a phase transition. This is thermal decomposition. Another theory is that contaminated air and materials are drawn into depressurized systems, and then those partition the chemicals into the water, and then from there, they then can sorbed or find their ways to people's taps. What we do know is that there's secondary contamination in the systems. This is where chemicals enter the system, they partition into air or water, and then from there they sorb or are attached to the surface of an infrastructure material like a metal pipe, scales, a biofilm, or they diffuse into those materials such as a plastic pipe like a sponge and red dye on a sponge and then come out slowly over time. So here's just 2 depictions of 2 of the hypotheses we believe. The literature supports both of them at the present time. VOCs and SVOCs can be formed during plastic pyrolysis as well as forced biomass combustion. And we think that this definitely needs an area of research. With regards to decontamination, science has been applied to some water distribution system testing and decontamination decisions, but more work is needed. There has been numerical modeling conducted by the US EPA with our assistance, where they basically predicted some assets would require 286 days of constant flushing at 2 gallons per minute for next almost a year to decontaminate it. And so what we've identified is that some assets simply have to be removed because they are too costly to decontaminate in place. We've also looked at chemical sorption and uptake into different types of piping materials and how long it may take for those chemicals to leach out over time. We have helped the town of Paradise kind of work out building water testing plans. They can understand if their commercial buildings are contaminated and what to do about it. And there's also been some discussions about what to do with the water that is chemically contaminated, because there's some regulatory issues associated with disposing of water with greater than 500 parts per billion of benzene. From a public health implication standpoint, standing homes is where the focus really needs to be. Water use advisories, there's two Delaware water company systems that are contaminated but have no water advisory. Some Ph.D. customers we know are not following the water use restrictions. They're told not to take hot showers, but they are. They're told not to drink the water, but they are. And we know this because they've called us and told us in the process of asking questions about their water safety. In April 2019, the Office of Environmental Health Hazard Assessment in California showed that 26 to 1,000 parts per billion of benzene posed an acute health risk to children, and some of those levels have been exceeded in the Paradise Irrigation District system as well as the Delaware Water Company system. We do know that contaminated water is entering and still continue to enter homes, so this is a public health risk. Utilities are still trying to identify their contaminated assets. They haven't tested all their service lines. They haven't tested all their hydrants yet, just because of the scale of damage. And then when they start fixing some of these systems, the loss of pressure or main break or leak on one side of their water system could draw contaminated water from the other side into the clean side of the system. So that presents a risk. Plumbing, many of these buildings, standing homes, have received up to 6 months of contaminated water. They've received it in their hot and cold water systems, so you could classify them as non-potable at the current time. And the next step would be to determine what it takes to make those systems potable again. There's different plumbing designs that would need to be factored in. There's different in-home treatment devices that some people are using. People are paying for water testing results. Some of the results are not representative, and I'm going to talk to you about that in a second, primarily because they're following the advice of commercial laboratories that are misadvising them, as well as following the advice of others that are misadvising them about how to collect water sample. Irrigation systems, some of them are damaged, some of them are contaminated. External water tank maintenance and microbial growth is an issue. Many of these standing homes purchased water tanks, and so these are microbial incubators potentially out in the sun if they don't have high water turnover. So this is an issue that needs to be addressed. It's been addressed in other disasters, and this disaster is no different. And one of the issues is one of your panelists talked about earlier this morning is the economic capacity, the financial well-being of some of these individuals that are affected. Some people called us here at Purdue and asked, what do? They have no money. They can't purchase bottled water. They can't purchase in-home treatment devices, but the water testing data that the utility has shows that the water is contaminated. So there are these types of struggles that happen in affected communities, and there really needs to be advocacy for these individuals. And then insurance companies making decisions about in-home treatment. I can't tell you how many times people have said that they've been kicked off their additional living expenses, or they ran out of their additional living expenses from their insurance company, and the insurance company assured them that in-home treatment makes safe water under any circumstance. And so that's a problem because the devices that are being installed are not tested for any circumstance. They're tested for typical drinking water use, not heavily contaminated use. On the right-hand side there, you see a picture of a house with a well, and in the surface water, what we have is this contaminated surface water. There's a question of whether or not that water will make its way into the groundwater, and then the contaminants will get into the well. That's one potential pathway. Another potential pathway is damage to the wellhead and contamination going down the side of the well to the pump. And so there's been some excellent guidance issued by Butte County about how people can test their well. Just a few more observations. more standing home challenges. When I mentioned that commercial laboratories were telling people to sample their home water incorrectly, here's an example. On the upper right-hand side, when sampling from a tap, open the tap and allow the system to flush until the water temperature has stabilized, usually about 10 minutes. So if you open your kitchen sink faucet and you let it run for 10 minutes, you're not sampling the house like you wanted. You're going to be drawing in many times water from the water main or the service line. And so this is an issue that many people have encountered. Some of the public and population is starting to realize this as they're doing testing different ways and finding contamination in some places and not others. Another way that people are struggling a little bit is they've been told to only look for benzene at the cold water kitchen sink with no stagnation, and this ignores the fact that their hot water systems have conveyed contaminated water, the basics of plumbing design and operation, chemical desorptions needed, and more. And so as you look into the communities, whether they be campfire impacted or the next wildfire impacted, realize that the people that are most important are the people that are affected, and providing them solid advice about how to help them recover is really important. So we've compiled 6 scientific challenges and opportunities looking ahead, and I believe this is one of my last 2 slides. And each one of these is a pretty loaded objective, but they're important. And looking ahead, these are the types of areas we think needs to be focused on. Determining the sources and sinks of chemical contamination, where exactly this contamination is coming from, what's causing it. If you can find out that certain components of a system are more vulnerable to causing that contamination, you could simply design away and not use them. Or you could better defend those assets from fire. Control for laboratory contamination and data reproducibility and SOPs. As of about 4 weeks ago, there were no standard operating procedures for how to take a water sample from a fire hydrant or from a building. And so there are definitely opportunities for education and advancements that the next time this type of incident happens, there are already things in place where people can jump off and respond more rapidly. Develop evidence-based water use restrictions that protect public health. This would be understanding inhalation exposure, modeling of emissions, volatilization of chemicals from the water under certain showering conditions, and then making water use restrictions based on those results. Obtaining data to improve decision-making for infrastructure testing, decontamination, and replacement. Much of the decisions that have been made prior to this fire were based on best judgment at the time. But best judgment at the time often was made without any data. The work by the US EPA on this recent fire and their modeling of contamination and decontamination of plastic piping has really took a giant leap forward here. But there's a lot to do, and there's a lot of space here to help make better decisions for infrastructure testing, decontamination, and replacement. The 5th item is really to determine the environmental and human health impacts of disposing of chemically contaminated materials. This includes the flushing water, the chemically contaminated water that's leaving the hydrants. People called and asked me if it was safe to use on their vegetables, if it was safe to give their prized landscaping, if walking by a hydrant that was misting was safe. And so these are all critical public health questions that need to be addressed. And then finally, determining evidence-based private property characterization of recovery steps. How does one understand how to decontaminate their plumbing or test it or start? So with that, I'd like to say again, thank you for the opportunity to talk with you today. If you have any questions, I'll be happy to answer them.